Good evening. I wanted to take a few minutes to walk through the practice problems for exam 2. Exam 2 will cover chapter 4, which is on capacity planning, chapter 6, which is on manufacturing processes, and chapter 12, which is on lean manufacturing and continuous improvement. There are no problems for chapter 12, excuse me, and it looks like this needs to be updated to say chapter 6. So we'll get that updated. Yep. So here's the problems. They'll be posted on Canvas under the exam review. So you probably will already have seen them because that's where this recording will also be posted. But let me go ahead and say, let's get started with the chapter 4 problems, which are about capacity. So manufacturing shop is designed to operate most efficiently at an output of 670 units per day. And in the past month, the plant averaged 570 units per day. What was the capacity utilization rate last month? Let me just check real quick here and see if I have a calculator. I do. So if I were typing out my answer in here, I would be saying something like that capacity utilization is equal to actual divided by theoretical. So in our case, actual is 570 units per day and theoretical is 670. So that being said, I'm going to find my calculator and I'm going to take 570 and I'm going to divide it by 670. And that's going to give me, oops, I wish that would stay up, but we're going to go ahead and do this. So it's going to give me 85.07% efficiency. So, excuse me, capacity utilization. So that's actual capacity divided by theoretical. If the best operating level of a piece of equipment is at a rate of 500 units per hour and the actual output is 400, what is the capacity utilization? We're doing basically the same thing that we did in the problem above, right? Only now our actual is 400 divided by our theoretical of 500, right? And that to me should be 80%. And I just do that by getting to 800 out of 1,000 if I double that. But if you did the math, 400 divided by 500, you should get 80% on that as well. Okay, so the next problem is basically checking to see if you understand that we calculate capacity utilization off of a specific set of numbers. So there's the theoretical of what we could do, absolute max, absolute min of theoretical, but then there's also the most efficient set of theoretical, what we can do. So this problem kind of gives us all three, and it expects you to understand that you need to select the actual and divide it by the most efficient operating level. So a company has a factory that is designed so that it is most efficient when it's producing 37,100 units of output each month. However, it can produce, or it has an absolute maximum output of 43,000 units per month and can produce as little as 22,000 units per month without corporate headquarters shifting production to another plant. If the factory produces 39,470 units in October, what is the capacity utilization? Okay, so we're still doing capacity utilization. And we're going to say that our actual was 39,470 and our theoretical, where we operate the most efficient, was 37,100. And so again, I need to get my calculator and I need to clear it. And then I need to say 39,470 divided by 37,100. And that gives me a capacity of 106%, which makes sense because we're producing more than what we were most efficient at. So I'm going to go out to the 2 decimal places here to get my percent. And we will move that decimal place to reflect percent. Okay. All right. And then it says, if demand for product A were forecast at 2 million units for the coming year, and your factory has one machine capable of producing 60,000 units, how much of product A might you plan to acquire through outsourcing? Okay. So what we're going to do is we're going to say, I have 2 million units, and we can produce 60,000 units per month. So I need to get my 60,000 units times 12, right? And if I'm not mistaken, that should be something like, let me just do it on a calculator because I don't want to get my decimal in the wrong place. 60 times 12, 720,000. So I may want to outsource then 2 million minus the 720,000. And I'm just going to do this kind of in one go. So 720,000 minus 2 million says that I'm going to outsource 1,280,000 units. Alternatively, you might be asked something like, how many additional machines would you need to purchase to reach your forecast? And I could get to that by saying 2 million divided by 60,000 is going to tell me how many machines I need, right? So that says that I'm going to need, oops, didn't do that quite right though, did I? What did I do wrong? One machine can produce 720,000 units. So that's what I need to divide by. So I need to come back and go, all right, so I've got my 2 million divided by my 720,000. How many units a single machine can produce in a year? And that tells me that I need 2.78 machines minus the one machine I already have. Says that I need 1.78 machines additionally, which we round up to 2. Okay. So that's your capacity questions. So I think that should be, you work through those 1 or 2 times, you should be in pretty good shape. Let's go ahead and look at our chapter 6 practice problems. Okay, so you've just determined that the actual number of workstations that will be used on an assembly line is going to be 9 using the assembly line balancing procedure. The cycle time of the line is 10 minutes, and the sum of all the tasks required on the line is 75 minutes. What is the correct value for the resulting line's efficiency? So to get to that efficiency, we have to remember that our efficiency is equal to the sum of the task times divided by the number of workstations times the cycle time. And I'll adjust this so efficiency is spelled right. Okay, so this is kind of calling on our memory to make sure that we understand that the sum of the task time says, as I go down the production line, all of the things that we have to do is going to take 75 minutes, right? But each workstation right? And we're going to have 9 of those workstations, is going to have a 10-minute time slot for each of those workstations. So we're going to have 75 divided by 90 is going to be what our efficiency is going to be. So again, come here, clear it, 75 divided by 90. And I can just do times 100, right, to get my efficiency percentage. Okay. All right, then we're going to move on to some break-even analysis or indifference point analysis, right? And one of the things that every college business student should know is that our break-even point is at that place where our total revenue is equal to our total cost, right? And so our total revenue is going to be our sales price times how many we sell. And our total cost is going to be our fixed cost plus our variable cost times how many we sell. So that being said, to find the indifference point, I find where X is equal given the sales price, the fixed cost, and the variable cost that we know. So the book sells for $23 a book. So that's 23X is equal to 300,000 in fixed costs plus $8 of variable cost. Okay, so then to solve for that, 23 minus 8 is 15X is equal to 300,000. So then X is equal to 300,000 divided by 15, which is equal to $20,000. So that's saying that our indifference point is 20,000 units. Okay, so that was A. And B says if management forecasts a volume of 9,000 units, what process would we use? Okay, so I think this is a kind of an amalgamation of 2 questions. So let me kind of bring this into play to say that the 2 processes I'm going to pause for just a second while I make sure that I have that question worded just like I want it to be. Now I just realized that my practice problems were a little bit convoluted there. So I squared this one up by just saying, let's identify the break-even point in this analysis. And the reason that we're doing that is because in the next problem, we're actually talking about when we say indifference point, we mean when I set 2 processes to be equal, I can find out the volume at which I should select one process over the other. And so that's what we're going to do with this problem. So using indifference point analysis, what's the indifference point between these 2 processes? So what we want to do here is set the total cost of process A equal to the total cost of process B. And so in this case, that's going to be the fixed cost of A plus the variable costs of A times X are going to be equal to the fixed costs of B. So again, it's just fixed cost plus variable cost, fixed costs of B plus variable costs of B times however many units we sell. So in this case, A says that our fixed cost of A is 80,000 plus 15X. And our fixed costs of B are going to be 120,000 plus our variable costs of B are going to be 10X. Yeah, so I need to make a quick adjustment here to the problem because that won't make any sense. This is what happens when you make up your own problems. You realize if I have a variable cost of $15 per unit on every unit, having a selling price of $25 doesn't make a lot of sense. Okay. All right. So here's our score. fixed cost of A plus variable cost of A equal to the fixed cost of B plus the variable cost of B. So that being said, it looks to me like 15x minus 10x is going to be 5x, which is going to be equal to 120,000 divided minus 80,000 should be 40,000, right? And so then if my math is right, then x is going to be, my indifference point is going to be 40,000 divided by 5, right? And so I think that that is 8,000 units. Does that sound right to you? 40,000 divided by 5 should be 8,000. Okay, so that's our indifference point. What does that mean to us? That means, I'm going to go ahead and put a page break so we can get this all on the same page. Okay, so that means that between process A and B, if I have 8,000 units, I do not care which process I use. If I have a forecast of 9,000 units, okay, then the question becomes, well, which process should I use? What you see is that with process A, we have lower fixed costs and higher variable costs. And with process B, we have higher fixed costs and lower variable costs. So what's going to happen is we're going to select process B, because anytime my forecast is above this indifference point, I'm going to be better off spending more capital up front and having the lower variable costs. If my forecast were below the indifference point, I would pick the lower fixed cost process, right? Because I'm not going to have enough volume to justify that capital investment. Okay, so the answer to this one is we're going to select, boom, we're going to select process A, or excuse me, process B, because our forecast is higher than the indifference point, and thus it justifies an investment, a higher capital investment process. Okay. All right. That's how you get through that one. Okay. Then question 4, using the assembly line balancing procedure, what is the required cycle time in minutes per unit if the daily production time is 400 minutes and the required daily output is 250 units? Cycle time is equal to required output, is equal to time available divided by required output. So in our case, it's going to be 480 minutes divided by 250 units. So our cycle time then is going to be 480 divided by 250. So that's going to give us 1.92 minutes per unit. So that gets us through our problems. And as you can see, we don't have any problems for chapter 12. So I hope that helps you prepare for exam 2. I'm sure I'll see you in class soon.